with the bands. Pose with the pose with the pose with the bands. Pose with the pose with the pose with the bands. Bands. Pose with the bands.
Hai and Assalamualaikum warahmatullahi wabarakatuh. My name is Wanur Amirah binti Wan Muhammad Asri. Today, my friends and I will present experiment 5, which is frictional force. Now, introduction. Force and velocity are vector quantity that have both magnitude and direction. Velocity is the speed in a specified direction with which a given object is travelling. Force exists when the object accelerates or undergoes a change in its velocity. A body at rest or in equilibrium inhibit, resultant force or the sum of all force acting on the body is zero. Gravity is an attractive force that exists between two masses. The magnitude of the force depends on the magnitude of the masses. The gravitational force that acts on an object of Earth is approximate as Fg equal to mg. Next, where m is the mass of the objects and g is the gravitational acceleration, the magnitude of the gravitational force exerted on an object is referred as its weight. Normal force is a contact force that acts in the normal direction or perpendicular to the contact surface between two objects. Figure 5.1 shows the free body diagram of mass m lying on the horizontal surface, where the normal force N is equal in magnitude to the gravitational force mg. Friction is the force that resists the relative motion of one surface in contact with another. There are two types of friction, static and kinetic. Static friction is the friction that acts on an object that is at rest. Static friction is the four frames that must be overcome in order to move a static object. The maximum of value of static frictional force is given by where is the coefficient of static friction and N is the normal force. The coefficient of static friction is a dimensionless constant that depends on the object and the surface is lying open. Kinetic friction force that acts on a moving object. The kinetic friction force is given by Fk equal to UKN, where UK is the coefficient of kinetic friction and N is the normal force. On this experiment, the frictional force between a wooden block and the rubber surface on the horizontal and inclined plane will be measured, and from plot data, the coefficient of static friction will be obtained. Objectives: to determine the coefficient of static friction of different surface. Apparatus: wooden block, rubber convert at one side, 15 G masses, 10 and spring scale, string and tabletop. The procedure: 1. The mass of the wooden block was to be measured and recorded as m. 2. The apparatus was set up as shown in the picture. 3. The tabletop was made sure stable and horizontal to the ground. 4. The spring scale attached and the wooden block with a string. Place them horizontally on the tabletop. The rubber side of the block was made sure face downward. 5. Place a m 15 gram mass on the wooden block. 6. The spring was pulled slowly. Once the block starts to move, the spring scale's reading was recorded. The value was recorded as Fs and was tabulated in table 5.1. 7. Step 4 until 5 was repeated for 3 trials. 8. Another 15 gram of mass was added on the block, and the step 5 and 6 was repeated. The steps were repeated until the total of m 500 gram is on the wooden block. 9. Step 1 until 8 was repeated, but this time the rubber side of the block was facing upward. The data was tabulated in table 5.2.
Okay, next is the analysis question. For question 1, draw and label the free body diagram of the wooden block. And the answer is For right arrow is force, left arrow is frictional force, upper arrow is normal force, and down arrow is weight. Question 2. Plot graph of static friction force against normal force for the rubber surface and non-rubber surface. Here's the answer for graph of static friction force against normal force for the rubber surface. And this is the answer for graph of static friction force against normal force for the non-rubber surface. Question 3. Use the gradient obtained from the graph to calculate the coefficient of static friction for each surfaces. For rubber surface, 4.0 minus 8.4 over 3.1 minus 8.5 equal to 0.815. For non-rubber surface, 5.0 minus 7.9 over 2.6 minus 7.0 equal to 0.659. Question 4. Compare and discuss the coefficient of static friction obtained. The answer is the coefficient of static friction for rubber surface is higher than the coefficient of static friction for non-rubber surface. This is because the material of surface affects the coefficient of static friction.
Okay, question number 1. How can anti-lock brake stop a car in a shorter distance than regular brakes? Anti-lock brake helps a car in a shorter distance to regular brake compared to regular brakes by preventing the wheels from locking up during braking. It works by wheel lock-up prevention, pulsing the brakes and improve the control. Question number 2. From your experiment, which material has the highest coefficient of static friction? Does this agree with your hypothesis, and what do you think determine the coefficient of static friction? Okay, from our experiments, rubber surface toward the floor has the highest coefficient of static friction. Yes, the explanation agree with the hypothesis due to the material's ability to confirm the surface irregularities and create greater surface contact. I think coefficient of static friction depend on the material intrinsic properties, their surface characteristic, and the condition under which they interact, such as cleanliness and temperature. Okay, question number 3. Once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. Okay. The motion of the mass sliding on the surface can be smooth or involve stop and go motion, depending on several factors such as friction, the nature of the surface, and any force acting on the mass. Next, let's see for discussion. In this experiment, we define two kinds of frictions, which are static and kinetic. When we added mass of wooden block on rubber surface, average of static friction force was increases same as on non-rubber surface towards the floor. Last but not least for conclusion. In conclusion, friction depends on the normal force. The coefficient of friction increases linearly with the normal force between surfaces.